Okay, so waiting on that last one on the video. This was, remember when I put in y equals 1.1 raised to the theta, just so that my base was a little bit smaller. And so when I did this graph and waited for it, you can see that it's the spiral. It gets bigger and bigger and bigger. Okay, so you're thinking of 2 raised to the theta, and as theta increases, then that radius is going to increase. So I'm looking at the theta is going around the circle, but then the radius is getting bigger and bigger and bigger, so it's going around. So the 2 was hard to see because 2 got big really fast, and it was hard to see all of that on the screen. So, you know, like I said, if you want to go back to what the 2 looks like, and you just want to graph 2 raised to the theta and look at what the graph looks like, and if all you see is just a little piece of it, part of it, then graph that piece. So if that's all you see and you want to graph that, that's fine. But I do want you to realize that this is actually going to go around and keep going around and be a spiral. All right, number 11 is theta over 2. So I put that on my calculator. I'm in radians as well, so my window I need to make sure goes from 0 to 2 pi we'll try. And this is another one I think, when you look at it, we may have to change our window a little bit, but if I start at 2 pi, and it's 0.1-ish about, go to zoom 0, I'm going to see that this one also looks like it's starting to spiral. And if you want to see more of that, you definitely could make this go to, you know, 6 pi or something, make it go longer into a zoom fit. So that you could see that it is spiraling as you go around. So it's another spiral. If you know, it quits here because the window has changed. So if I want to, I can say I'm going to not change my window. I'm not going to do a zoom, but I'm going to go to 10 pi or something a little bit bigger than that and hit graph. So I'm still going to see the same window, but now it's going to continue to go, and then it goes out of my window. Okay, but that is also a spiral. So when you go to graph this, just, you know, draw this in and know that it starts at 0, 0, and it's just going to keep going. Because again, the radius is getting bigger as theta gets bigger. But this isn't getting bigger exponentially. So as theta gets bigger, theta over 2 is getting bigger, but it's not exponential. So it's easier to see that in a window than it is this one. Okay, but they both are, the R values are getting bigger. Okay, and then this one, you have R squared. So, you know, it's kind of like when you have y squared or x squared or y squared and your y equals. How do you get that to be y equals? Well, you got to take the square root of both sides. But you have to remember it's plus or minus over here. So in our calculator, we're going to have to put, for R, we're going to have to put positive square root of 9 cosine 2 theta, and R equals negative square root of. So that's what we're going to have to put into our calculator. So I did that. So it looks like this. This one, I guess we haven't done one in degrees, so let me do this one in degrees. I'll go to degrees. My window, I want to go from 0 to 360 then. We'll see if 360 works. Maybe we have to go something different. And I'll do 1 degree. And I'm going to do zoom 0. So just to show you, degrees works as well. You just have to make sure that then your window, your thetas go from 0 to 360. And so it's thinking about what it's going to look like. I did go degree of 1, or step of 1, so that's probably why it's taking so long. I think if you went a degree, like a step of 5, I think you would have been okay as well. So it starts here at 3, 0, comes down back to 0, 0. Now you're going to notice a little bit of a delay, like it gets here and then it delays. And you need to think about, well, what's going on? Why is there a delay there? So it really makes like a bow tie, I always think of it as. So it makes this bow tie, and it looks like it goes out to 1, 2, 3, and out to negative 3. So that's what it looks like. But you should have noticed when it was doing that, that there was a delay. And so if you do a trace, you'll notice that, okay, remember this is in degrees. When theta is 0 degrees, I was at 3, 0. And here's theta changing from 0 all the way. I shouldn't probably went by ones, but everything looks okay. It's moving along the circle, the unit circle. Once I got to 45 degrees, it was at 0, 0. When I hit 46, it's undefined. So then you have to ask yourself, why is it undefined? And if you want to, stop the video, pause the video, and see if you can figure that out before I tell you. Like, why would it be undefined at 46 degrees? All right, so if you haven't delayed it, or if you did and thought about it, remember that you're taking the square root of this. So once you put in anything over 45 degrees, like 46, this says you're going to take the cosine of 2 times 46. Well, that would be the cosine of 98. And think about where 98 degrees is. That's going to have a negative cosine. So you're going to take 9 times some negative number. So when this value is negative, it's undefined. So that's why when I go to here, I see that at 46, my x and y are undefined. I don't have an ordered pair there because the radius is undefined. And as I keep going, everything here, all of these thetas are really values. When I double them, they're giving me a cosine that is a negative number. I can't take the square root. And that's going to happen all the way until I get to, where do you think? Well, it's going to happen when I get to 180 degrees. Because once I get to 180 degrees, and it's going to take me a while, oh wait, 145, I'm sorry, or 135. Because once I get to 135, let's think about that again. Once I get to 135, when I take 2 times 135, I get 270. 270 is down here, so once I get past 270, now it's going to be a positive cosine again. So yeah, so it's 135 is where it's going to start happening again, and now those are all defined, so we'll go through. So because you're doubling this angle, this 2 theta, anywhere where that cosine of 2 theta is going to be negative, that's when the square root was undefined. So that's why when you saw it graph, even though you don't see the undefineds, you definitely see there was a pause because it was trying to graph, like it was trying to calculate those and they were undefined. So it just kept going until then it picked up again once theta was 135. Okay, so it really looks kind of like a little bow tie, I guess. I don't know what else, what other picture you want to look at. I think it looks like a pair of eyes, I don't know. But there was a spot where some of the theta, some of the r's were undefined because of that cosine being negative. Okay, and then, and one note on that, if you try to do that in radians, sometimes because of the pixels, you might get some empty spaces there. So just realize there might be some spots where it looks like there's empty spaces, but it has to do with the pixels of your graph. All right, let's look at the last one real quick. This one is a review of what you did, but just a little bit different way to ask it. So I told you you have an ordered pair, radius of 6 and a theta of 8 pi over 5. So 8 pi over 5 would be here with a reference angle of 2 pi over 5, because that would end up with 10 if I got all the way over to here. So the reference angle is 2 pi over 5, and it's a radius of 6. So I want to name this point. I don't want that point to change. That's the point that I'm looking at. So A says, let's rename it. Theta is still between 0 and 2 pi. So it's still got to be some answer, some angle between 0 and 2 pi. But now it's saying that the radius has to be negative. So instead of being a positive 6 radius, what this piece is telling me is that r has to be negative. So I have to make it negative 6. So if the radius is negative 6, which means once I draw my angle, I need to go backwards to get to this point. That tells me the angle I name has to be this direction. So whatever that angle is, if I draw that angle and then go back 6, because it's negative 6, I'll end up at that spot. So what is this angle? Starting here and going to that angle, that terminal side. Well, if this reference angle is 2 pi over 5, then this angle in standard position is 3 pi over 5. So if I grabbed 3 pi over 5, which is this vector, and went to negative 6, so it means I have to go backwards 6 units, I end up at that same spot. Okay, so let's try the other one. It says r has to be positive, so I know it has to be 6. So I know that I want to go in the right direction, but it says I have to name a negative angle. It has to go between negative 2 pi and 0. So I need to start here and go in that direction. I need to get to this angle because I want to go positive 6. So what is that angle? Negative 2 pi over 5. Because the angle has to be negative is what this is saying. And then the last one, r has to be negative, so I have to use negative 6. So that means if I'm using negative 6, I want to name this terminal side. Because if this is my terminal side, and I want to go negative 6 to get to that point. So I need to name that angle, but between 2 pi and 4 pi. So that means I have to go around once 2 pi, but then I have to go an additional, what is that? We said 3 pi over 5 is that angle. So I want to go 2 pi plus another 3/5 of a pi. Well, 2 pi is 10/5. So I want to go 10/5 pi plus another 3/5 pi. That gets me at 13/5 pi. So this is just making sure you know how to name them a different way. Okay, so that is page 2 completed. You know, just take your time, go back and, you know, have a little fun. Maybe you call it fun, I call it fun. Going back and trying to change some of these numbers to see really what is affecting that graph to make it do that. You also might want to do the square just to make sure you can see what it looks like when you do a zoom square. Okay?